Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, let's take a look at this problem here. So, we're given a particle traveling in circular motion, and we are asked to find the time it takes to complete one period after it goes around one whole track. So, we know that the time it takes for anything to travel a certain distance is equal to the distance for a circle. The total distance is 2 pi times the radius. The time it takes for it to travel that distance is the distance divided by the speed of the particle. So we have time is equal to 2 pi r divided by velocity, or speed. The direction doesn't so much matter when it's traveling in a circular path. So okay, we're given a few things for this problem. We are not given the radius, however, so we can't just plug it straight into this. We do, however, have an equation to find a radius. Radius, r, is equal to mass times velocity divided by absolute value of the charge times the magnetic field. Now the only reason for having the absolute value of the charge is to put emphasis on the fact that it doesn't matter what the charge is, whether it's positive or negative, it doesn't matter, it won't play into effect here. So they're just taking the absolute value of that to put that in emphasis. So now we have an equation for r. We are given the mass to charge ratio for this particle and the magnetic field. But we don't have velocity, so let's rewrite this problem solving for velocity. And to do that, it's just simple algebra. You would multiply both sides of the equation by the denominator here. You have q and b. I'm going to skip writing down the absolute value signs because we know that it doesn't matter what the charge is. As long as we keep that in mind, we don't have to keep writing those down. At least for your own notes. If you were doing this for an exam problem, you'd want to keep those. So multiply both sides by the charge and the magnetic field. That'll cancel this side. I'm going to write v here. And then we divide both sides by m. So we have the radius multiplied by the charge and the magnetic field divided by m. We are given in the problem the charge per mass. So just to make it look like what we're given, we can rewrite it as the charge per mass on its own multiplied by the magnetic field times the radius. So now we found what the velocity is equal to. And we have velocity in this equation here. So because these are equal, we can plug this part in for this v. And if we look closer, you can see that we have an r in the numerator and an r in the denominator. So those will cancel, which is good because we don't have a value for r. Now we don't have to worry about it. So now rewriting, we have the time, which is what we're after, is equal to 2 pi So we have this number here, and we have this number. This is all in the denominator. You can just multiply those two numbers together, and then divide 2 pi by that. And you'll have your answer multiplied by b. So once again, you have the number for this ratio. Multiply that times the number for the magnetic field. That will give you the time in seconds. All these are in SI units. You don't have to change or convert anything. That'll give you your value of 1.5 times 10 to the minus 8th. and that is in seconds. 10 to the minus 8th seconds. And there you have it.